starting challenge 2, the dilution calculation.
It's 2.1.
And this is our 20% salt solution in this beaker right here. We have our 10 milliliter pipette. We have our volumetric flask, our 25 milliliter volumetric flask, and our bowl to draw it up. First, I'm going to draw 6 milliliters into this pipette. And right there we have 6 milliliters, and if we put it up a little bit closer, we can see right there the meniscus is hitting right on that number. And we're drawing up to 4 because we're going to do 1, 2, 3, 4, 5, 6. That way we have our true 6 milliliters. And I'm going to go ahead and transfer it into this flask right here. Get it all in there. I now have my water, which I'm going to go ahead and pour into this flask right here up until this. It's very hard to see, but you can kind of see right through that little line for 25. And now that we have our solution in here, I'm going to go ahead and take it over to the balance and measure it. Real quick, I'm going to go ahead and record that I did 6 milliliters of the stock solution. In my lab notebook, I have recorded all and got my concentration value and my density. So now on to trial 2.
Find the slope of the line.
So but that's challenge 2.
Right. You have to do challenge 2.
Okay, and now I'm going to get 4 milliliters of our diluted solution to pour into our flask. And right there
Wait,
again.
did you have to make the unknown solution?
Yes, it's at 6, but we have 1, 2, 3, 4.
Okay, that's what this is.
And the
Yeah, you need the
meniscus is right
density
at
of
that
the
6,
solution.
just like we want. And we're going to go ahead
Okay,
and put it
so I have the
into
density of
here.
it.
Just like that.
Well, we'll do that when she's done that. So we're almost done.
As you can see, I'm further diluting the already diluted stock solution in the flask. A stock solution is a concentrated solution of a known concentration that will be used for diluting. The diluted solution is a solution where water has been added to a certain amount of the stock solution in order to decrease the concentration and therefore dilute the stock solution. The dilution equation is M1V1 equals M2V2. M1 and V1 represent the molarity and volume of the initial concentrated solution, and M2 and V2 represent the molarity and volume of the final diluted solution.
So now we are going to go ahead and put it on this balance, and we're going to get this final mass real quick, which is 44.096. Okay, and then right here we have our trial 2 concentration and what we got and our density. Okay, now I'm going to get 2 milliliters of the solution, and we are at that 8 for that 1, 2 down there, and then we're going to go ahead and pour it into our flask right here.
You've probably heard the word meniscus mentioned multiple times in this video so far. The meniscus is the curve at the surface of a liquid in glassware. It is caused by the cohesive forces between liquid molecules and the adhesive forces between the liquid and the walls of the glass tube. This is also known as capillary action. In order to read a meniscus, you measure at the center of the curve that is formed, in this case, the bottom of the meniscus. The next clip is an example of the meniscus hitting right at the 25 milliliter mark on the volumetric flask.
Okay, we are back at the balance to measure that mass. Let's see what we get, 44.018. And now we have our third and final trial, which is where we use that concentration, and this is what we got, and our final density.